Oh, where's my soundboard? Hail. Oh, I gotta plug this in. There we go. There we go. Bum, 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 bum. What's up, Suave? Here, Suave, you wanna come up? Let's help you out with some math. Or physics, right? We're doing some physics? That's what we gotta do. Physics!
Yes, sir, we're doing some physics.
I love physics!
Yes, okay, so the thing is, there's some like extra little like I don't even know what to call it. It's like pre-lab stuff.
Okay.
That I was wondering if you could also help me with.
Yeah,
If
no, I'll
not,
check it
that's
out.
cool.
No, it's cool, it's cool. We got time.
But
We got time, dude. I don't gotta go nowhere till when do I go? I don't gotta go nowhere for like 3 hours. I got a short amount of time. All right. Yeah, let me help you out real quick. Oh, Swux has something too. What's up, Swux? Swux, I appreciate you having stuff as well. Here, let me copy this in real quick.
wait, are you fine if I go get my notebook real quick? It'll take
Go do
like
it.
10 seconds.
Go. You're good. You're good. You're good. Let me see what this is, and then Swux. What did you ask? Let me get your stuff out too.
Okay, I'm back.
All right. Cool.
Hold
All
up,
right.
it is physics time.
It is physics time. We love physics. We love physics. Dun, 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 dun. Okay, cool. All right, let's do this real quick. All right. Incline track, theta, there's L, cool. The purpose is to validate the work kinetic energy. Okay, cool. Awesome. Okay, cool. Whatever. Yeah, great. Okay, cool. Okay, independent variable. This is the thing you measure, I guess, right?
Yeah.
Card match. That can be measured with a triple balance beam. Okay. Cool, cool. All right, so do you know how work energy works, first off?
Work energy, it's the net. I know it's WNC equals
Yeah.
E final
Network is
minus E
equal to
initial, right?
network is equal to the change in kinetic energy is what we say, right?
Okay.
Good.
Yeah.
So what's going to happen is as this cart moves down, right? Work is related to like what forces are acting on it, right? Work, let's remember, is equal to F dot D, which is the same thing as FD cosine theta, all right? Which is just saying the amount of force in the direction of the distance, okay?
Okay.
So on this cart, as this cart moves down towards the photo gate, right? What forces act on it?
Gravity.
Gravity, right? Gravity just points down. Any other forces?
There's no spring force, is there?
There's no spring. There's no
not.
nothing. Technically, there's
Just gravity,
friction.
yeah.
There's technically friction, but
Oh
whatever.
yeah.
We'll,
Friction.
we'll ignore it. I think you ignore it in this point. A lot of times with these physics things, we just ignore friction. Okay, so here's the
They didn't give
force.
any, like, coefficient.
They didn't give any coefficients, right? This is the force of gravity, right? Pointing down. All right. So that's gonna be equal to mg, right? The distance it travels, right? What's that equal to?
Length.
Length, right? That's gonna be L, right? And then cosine of theta, that's just this, cosine theta. Right?
Yeah.
So this is the net work that gets done on the object. It's the force of gravity that's being pushed at this distance, and this is the angle between the two, all right? So you have mgl cosine theta is equal to the change in kinetic energy, which is going to be 1/2 mv final squared minus 1/2 mv initial squared, right? Delta is always final minus initial. And then kinetic energy is 1/2 mv squared. Does that make sense?
Yeah, it does.
Good. Cool. All right. So, do you see how the masses cancel?
I do.
No more masses. Mass doesn't care about this, right? Okay. So, and then you're going to use a photo gate probably to do something. What are we going to use the photo gate for? Photo gate's going to measure speed. Okay. We're going to measure the speed of the cart, right? And I assume these things start at rest, right? We hold the cart
they
up the
started
top.
rest, yeah.
Good. Awesome. So V initial is 0, okay? So literally this is all I have. I have GL cosine theta is equal to 1/2 V final squared. Okay? So if I can measure what the final speed is based on the length, right? What are we trying to figure out? What do they want to figure out? What's like usually there's okay. The purpose of the laboratory is to validate by developing a linearized model to the objective quantity, the magnitude of the acceleration due to gravity. Okay, they want to solve for g, is what they're doing. They want to show that g is something. Okay.
But isn't G just 9.8?
Yeah, but we want to show experimentally that g is 9.8. Oh, I'm very proud of you, Monkey Dude. 10 win streak. That's cool. Awesome. Yeah, we know that g is 9.8, but what we're gonna show here is that if we graph some shit, we can calculate what g is experimentally, and then basically validate that it should be 9.8.
Oh, okay. I see what you're saying there.
So, and let me think. Are we doing different trials of like different lengths? I don't think so, right? Are we doing different? Maybe we are doing different lengths. Develop the model using pros, dude. What the fuck is this, dude? What?
I don't think that really matters. Don't worry about that.
Okay, this is so dumb. All right, whatever. Okay, here's your free body diagram. Technically, if they want it, right? This is normal force. Okay. And you're gonna measure L. Here's what I'm guessing is gonna happen. We're gonna vary L, and then we're gonna measure VF squared, and then we're gonna get what the slope is. So here's kind of how this is gonna work. So I'm gonna say VF squared is equal to 2L cosine theta times G. Okay? Do you see how I rewrote this? I just put this over here and then whatever, right?
Yeah. Wait. Why wouldn't 2L cosine G be negative?
We're gonna get there. Okay. Well. Yeah. Okay.
Didn't you just switch it over?
Yeah. Well, here's the thing: is that the G we're gonna solve for here is probably gonna end up being it's gonna be a positive number, but don't worry. G doesn't have G doesn't have a direction. G is always equal to 9.8. What A is sometimes equal to minus G is what we say. The minus signs in physics just refer to the direction. You literally we won't be able to get a negative here just because of how this works. Okay.
Yeah, I see what you're saying because they're
okay. So if I were to graph this as y, right, is equal to, and then let's say that all of this stuff right here is like my slope, okay? And then this is going to be g, this is going to be my x. Do you see how this describes like the equation of a line, y is equal to mx?
Yeah.
Where b is equal to 0?
Well, oh, yeah, okay, I see what you're saying. Yeah.
See, y is equal to mx plus b. Okay. So if I graph VF squared versus this basically, or actually no, sorry, let's no, this is actually what I want to. No, I fucked this up. Sorry, I want to move this around. I want this to be I want this to be g, or here I want this to be g cosine theta, and this is times L. Okay, sorry. So what I'm going to do is I'm going to vary the length that I start this card at, okay? This is X. And I'm going to measure what...
How did we lose the 2?
Oh, there's sorry. No, you're right. There's a 2, sorry. I'm going to measure... I'm going to put in for different lengths, right? I'm going to measure what VF squared is, which is my Y. And then the slope I get from all these points will be equal to 2G cosine theta. And then from that, I can then solve for what G is, because I know what 2 cosine theta is. This is what's going to happen. Like, imagine on your y-axis here, you have VF squared, and imagine here you have L, okay? You're going to end up having, hopefully, a bunch of points here, right? For instance, like, if my length is equal to, I don't know, like 3 meters, my VF squared is going to be, I don't know, it's going to be... now I want to be like correct just because I know it's an inverse square relation. Let's say this is 4 meters. My VF is going to be like 2. And then if this is, let's go even further out. Let's say this is like 16 or something, right? Then this should come out as a VF squared of 4. And then whatever this is, right? This is going to be like y is equal to mx plus b. Remember that the y was the VF squared. The x is the length, right? That's what we're changing. And then so the slope of this thing, m, is the same as this, 2g cosine theta. So whatever I get for my slope, I'm going to say, okay, so slope equals 2g cosine theta from my points, from my graph here. And then I can solve for g. I can say, oh, g is equal to the slope divided by 2 cosine theta. I can go over that again because I know this is a lot. There's a lot that I've gone over here.
Yeah, it's a little bit to take in. But,
it's a lot. Okay. So in general, if we have like an equation, this is an equation, right? That relates things, right? Network and kinetic energy. Okay. I want to make this look like something where it's like y is equal to mx plus b. Okay, where this has the variable I'm trying to validate. This is what's called the dependent variable, and this is the independent, okay? So for instance, this is the thing you vary. Do you remember the difference between independent variables and dependent variables?
Yeah.
So independent variable is the thing you change, and then the dependent variable depends on what you changed. So when you're doing this experiment, right, of dropping this cart down, you can't really directly vary what the speed will be at the end, but you can vary what length you have it drop. That's why the length is the independent variable. That's why that's the thing we're going to vary. And based on that length, the final speed, VF, is the dependent variable because that's the thing that's going to change. Closer?
Yeah. No. I'm just thinking about it, but it's making sense. You're fine.
It's starting to make sense, yeah. If things don't make sense, you tell me. I mean, that's the whole point of this. Your teacher will just blab like fucking crazy, and like you'll just be like, I don't know what's going on.
Okay, this might be a big ask, but do you mind just filling those out just so like I know what's what? Just for like,
I'm gonna get here. Right, yeah, okay.
Okay, thank you.
Yeah, the independent variable, right? The thing we're changing, that is L. The dependent variable, that's gonna be VF squared. Okay, that's the final velocity. And then the equation is literally what this is, right? It's this. It's VF squared is equal to 2g cosine theta times L and then plus 0. So, let's make this like fancy L. That's how I usually draw things, okay? Independent
fancy L.
Yeah, I know, it's like script L. Independent quantity. This is the x variable. Well, we already said that. What? What?
Oh, maybe it's asking for like
the units. They want the units or something, or what?
Maybe it's asking for like the actual like value, or no? Then it would say value.
Oh, the objective quantity, which is the magnitude of acceleration due to gravity. Okay. This is the x quantity for the linear model as a function of the Oh, okay. That's a weird thing to say there. As a function of the dependent variable.
Wait, what is it asking?
I don't know. Dude, this is actually really... I mean, the x is this. That's the length. Just the length. What? As a function of the independent variable. What? 1 sec. I think the independent quantity... No, that's the objective quantity. Okay, this is what you're solving for. You're solving for G. And then the other measure variables with uncertainties that are not independent or dependent variables. Right, that's cosine theta. Or you can say theta. I'm a little confused what they're asking for here, honestly.
You know what? I mean, it's due tomorrow, so I'm just going to see what other people said.
Yeah, see what they say this. I mean, this is correct. I think maybe this is what they're saying. Sorry, this is what they're saying. So this is VF, this is L, and then this is VF squared. Like we're squaring this. Oh, okay. I got it. I think I got this. The independent quantities is technically L. 2L cosine theta is what it is. Right. Yeah.
Wait, is v squared just acceleration, by the way?
Yeah.
Or am I?
No, v
Okay.
squared.
I
V
was just
squared is
making sure.
is final velocity squared. Acceleration is dv/dt. That's where that comes from.
Okay.
Oh, okay. I think I see how this is working now. Okay. Sorry. All right. This is. Remember how I said y is equal to mx plus b, right?
Yeah.
This I think this is what they're calling the Wait. They're separating this out completely. This is such a weird way to do it, but okay. They're doing it like this. They want this to just be the slope, and they're calling this whole thing the x. They're calling this whole thing x. You're really just changing the length, but you have to also multiply it by 2 cosine theta. And then the thing in front of this, the slope, that's just going to be g, which is what you're solving for. This is weird. I don't like how they do this. I don't like that they define these things as two different things. I think it's confusing, honestly. It confused me at first. Really, it's just like, what are we changing? What are we measuring? And then what are we getting? That's what it should be.
Okay.
Yes. Okay. This is okay. Control variables, other variables with uncertainties that are not independent or dependent variables. Good. Yeah, theta. Theta is the only thing that's just not an independent or dependent variable. Write an expression for your slope of the equation in step 2. Okay, in step 2, well, the slope is this, right? This is 2g cosine theta. Using your expression for slope, determine the formula for the objective quantity in terms of the slope. There you go. So if this is the slope, right? Then g is equal to the slope divided by 2 cosine theta. You see how I just took this and put it underneath.
Okay.
Y-intercept should be 0. And utilizing your expression for the y-intercept, determine the formula for the objective quantity in terms of using your expression for the y-intercept, the objective quantity. It's nothing. There is no intercept. I don't think there should be an intercept. No, there's no intercept. Yeah, I think this is also 0. That's what I would say.
Okay.
Cool. Does that make a little bit more sense? There's a lot to it.
I think so. Wait, so is there like no definite answer? Was that question there asking like for
Which
no
one?
specific answer?
For what?
Like
For
the
step 8?
actual.
For which one? This?
No, not for the steps. For the actually like the diagram it gave you of the
Oh,
cart.
this. I don't think they're asking you to draw a force diagram. Is what they want you to do. So you should draw a force diagram.
Oh, and you're just trying to find g.
This is equal to mg is what this is, and then this is the expression of what's happening. Is that the work is equal to mgl cosine theta, which is equal to the change in kinetic energy. That's the equation. And then here I'll include that. That's what all this is. So here, yeah, I'll save both these things for you. Yeah, I've never seen them write out objective quantity and what. Usually it's just like, what's the independent variable, what's the dependent variable, what's the slope, how do I use the slope to find out what I want. That's usually what it is. There's swals, and then you need this one as well, right?
Yeah.
Yeah. When you do this lab, come to me for help, and let me show you, because I think once I have data, I can show you. It'll make sense to you more. If I'm just doing this all theoretically with variables and stuff, it's not really gonna click yet. But if once you have data and I show you graphically how this works, I think it'll make a lot more sense.
Okay. Yeah, no, I mean, I gotta set up groups, and then I have to do a whole spreadsheet, which is about to be a pain, but
Well,
it
yeah,
is what it is.
once you have data, I get it. Yeah. And I can show you how to do the spreadsheet for this. This is I understand how this works. But you need data first. So you're going to turn this in as the pre-lab, then you're going to go take data, right? So the data you want to measure, if they ask you to measure stuff, just for a little heads up, the data you're measuring is you're measuring VF, the final speed, and you're measuring L, the length at which you place the cart. These are the things you're measuring. Okay?
Okay.
So this is the thing you change, and this is the thing you measure with the photo gate. And then once you have all these points, then I can show you how to solve for G.
Oh, for sure. All right.
Cool?
Appreciate it, man.
All right, you're welcome, dude. Nice. Yeah. Always come by if you got questions, dude. I got you.
All right, appreciate that.
Yeah. All right, Swux. Let's get you up here, Swux. What's up, Swux?
Howdy.
Howdy, howdy, howdy. Have I seen you in a while, Swux? I don't know. I see so many people in this Discord. I forget like who's here and whatnot.
It's been a minute. I was here for like one other stream.
Oh, okay, cool. All right, nice.
Yeah.
You got some math questions, it looks like. Oh, we're doing cost analysis shit.
Optimization
Oh, yes, optimization.
That's dope.
I actually like optimization. You probably like, I don't like optimization.
I hate it.
It's the thing that's actually useful from, you're in calculus, right? This is kind of calculus. Yeah?
I'm in calculus.
Optimization is probably one of the most useful things you learn in calculus. In terms of like real life stuff, because it's used for finding, you know, what's the most effective price way to do something.
Yeah, makes sense.
I mean, we do this all the time in real life. You know, I'm like, okay, I could either buy, you know, an 18-pack of beer or I can buy like 2 bottles of wine. Like, which one do I do? You know?
Yeah.
There are rates for things. There are optimizations. You're like, what's the maximum amount? I don't know. Like, yeah. Okay, let's do the first one. 59 here. I like this. All right, let me throw it on the screen. Dun, 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 dun. A piece of wire 40 centimeters long is cut into 2 pieces. One piece is bent into the shape of a square, and the other is bent into the shape of a circle. How much should the wire be cut so that the total area enclosed is minimum? Ooh, I like this. What's up, Unaccessible? Okay. Okay. I like to draw pictures. Pictures are like kind of cool, right?
Yeah, I'm getting graded on pictures too.
Okay, that's great. We're getting an art degree while we're at it.
Oh, yeah.
Okay, this is the wire, right? Whenever I have, oh, you have an interesting optimization question? Can I ask it now? Yeah, post it in our RGBT. Post it in our Discord. There you go. That's our Discord. Join our Discord if you're not in yet. And then there's a help screenshots channel. Drop a screenshot of it. It's right.
You got baby voice going. Is baby voice working today? But yeah, this is the channel that students post their screenshots, and then yeah, I'll go through it. Oh, what happened to stage chat? Discord decided to crash. God damn it! 1 sec.
One sec. Yeah, Discord crashed. I don't know why Discord crashed on a screen capture. Like, dog, what? Here, let me pop this out. 1 sec. Pop out. There we go. We're back. And then I need this, and then I need to share my screen. Discord. Here we go. Okay, we're back. All right, you can see everything, Swux? Yeah?
Yep.
Good. Okay, cool. Sick. All right. All right. So here's what we have. We have this 40 meter piece of wire, right? And then what's our choice? I always like to ask, like, what's our choice? What option do we have? What are we supposed to be doing with this 40 centimeter piece long of wire? Like, what are they asking us to do?
So we want to cut it into 2 pieces.
You want to cut it into
One's
2
a
pieces. Yeah, very good, right?
circle.
So our option here, right, is where do I cut it? Right?
Yeah.
If you're given the wire, you're like, what do I do? It's like, where do I cut it? That's what I'm going to do. I'm going to refer to where I cut it as like X, okay? So that means one segment of the wire is going to be X, and the other segment of the wire is going to be what? How long will this thing be? If this is X, and I know the whole thing is 40, how long is this part?
Call it Y.
Y? Okay. Look,
Yeah.
you're good. Your mic's good. Let's call it 40 minus X, because I don't want to.
Sure.
Another thing with optimization problems is you need everything in terms of one variable. So in terms of one
Right,
choice.
right.
So if I'm calling this x, you're right. I could call this y, but then now we have two variables, and it's hard to do optimization with two variables. So I'm going to call this 40 minus x. All right. Okay, so then let's go over what the areas would be. Okay. So if we had the square, right? What would the area of the square be?
X squared. Or,
Okay.
sorry. Wait.
So this is x. This is the total length. Let's say this is x, right? I then have to break this up into
Or-
how many segments?
Right, 4.
4 different segments, right? And each one of those segments will have what length?
X over.
X over 4. Good, right. So this is going to be x over 4 squared. Okay?
Yeah.
All right, good. All right, so now let's look at the circle. Okay? This 40 minus x, what does that represent?
Perimeter.
That is the perimeter. Good. That's the perimeter, right? This whole thing is 40 minus x, which is also, yes, you're right, equal to the perimeter. What's the equation for the perimeter?
Is it 2 pi r squared?
Just 2 pi r. Okay, 2 pi r is correct.
Oh, okay.
All right. The reason why I need this is because what is the area of a circle?
That's pi r squared.
Good. This is pi r squared. Okay. But again, remember how I said everything has to be in terms of the same variable, right?
Yeah.
So I don't want to put r's in my equation. I want to just put things with
Right.
x. Do you see how this is a relationship between what the r is and what the x is?
Yeah.
So if I rearrange this, okay, I'm going to get that 40 minus x over 2 pi is equal to r. Right?
Right.
So now the area of the
Okay.
circle is pi times 40 minus x over 2 pi squared. Okay?
I see. Yeah, yeah.
Yeah, right? So now and we want the total area to be minimum. Okay, so now the total area is this plus this.
Mm-hmm.
So total area is equal to, this is x squared over 16 plus, this is pi squared and this is 4 pi squared. Sorry, this is pi over 4 pi squared. So this is 1 over 4 pi. That's just what this simplifies to. And then this is going to be, what's that? 1600 minus 80x plus x squared? I think so. Yeah. All I did was expand this out using the,
Yeah.
right? Good. Okay, cool. Yeah. I will skip some steps, but again, if any of the steps are like, wait, how the fuck did that happen? Just yell at me. I'll
Yeah,
break it down
for
more.
sure.
Cool. All right. So, cool. We can call this whole thing y. I don't care, right? So now we have an equation, right? That is just in terms of x. Do you see how we just have x's in here? This is great.
Yeah.
Yeah. That means we've done the right thing. If your equation has other variables, like for instance, if this instead like said pi r squared, that would be bad because
Right.
I need one variable to take all the derivatives with. Okay.
Mhm.
So dy dx. Now this is the calculus part, right? Is taking the derivatives of all this. You know what the derivative of this is? What's that?
2
Mm-hmm.
times x over 16.
Good. Same thing as x over 8. Okay.
Yeah.
And then plus 1 over 4 pi. Derivative of 1600 is what?
0.
0. Goodbyes. We don't care about that. This becomes, right, negative 80, and then this becomes plus 2x. Okay?
Yeah.
And we want this derivative to be equal to what? For it to be a maximum or a minimum?
0.
One equals 0. Good. Yeah. Right. And that's why we learn all that in calculus. We learn like this stuff, right? Like when the
Yeah.
derivative is 0, it's either a max or a min or something else that's weird. Okay. So, I'll see if I can do this without a calculator. Otherwise, I might need to do one. Because this is, what's this? Negative 20 over pi plus x over 8 plus 2x. Ew. Is that 17 over 8x? I think that is, right? Equal to 0. Right? Yeah, 16, 17. Okay, 17 over 8. Okay, this is just not a nice number. Okay. So 17 over 8x is equal to 20 over pi. Multiply everything by 8 pi. Oh, yeah, that would probably make things nice. I guess I'm going to have to do it anyways. 160 over 17 pi. Is that the same thing, Penn Center? Did I do something wrong? One sec. I like his idea here. He just says multiply everything by 8 pi. Yeah, because this does actually make things kind of nice. If you multiply everything by 8 pi, this is negative 160. And then this is plus, the 8's cancel, plus 17 pi x is equal to 0. Okay, yeah. So, x is equal to, it's the same thing. 160 over 17 pi. Oh, wait, yeah, over 17 pi. I hate fractions? Yeah, I hate fractions too. Not as much as I hate geometry. Yeah, okay, cool. Okay, that's your solution apparently, right? So you should always check this though, Swux. You should always check that this like makes sense, right? That this is valid. So I got to figure out what that number is. So give me a second. Let me put it on my where's my calculator? Where's my calculator?
I'm just thinking about the derivative thing.
What's up?
With the 1 over 4 pi times the stuff in brackets.
Mm-hmm.
If it's a function within a function, isn't there like a chain rule thing? Where you
There
have to pull it
is.
out?
There is if this has x in it. If this is just a constant, right? You see how these are just numbers? You can go ahead, take the derivatives inside, and then multiply out afterwards.
Okay.
The example for that is, let's say, for instance, I have 3x squared versus, let's say, 3x squared, okay?
Mm-hmm.
If I take the derivative of this, right, this is just 6x.
Yeah.
If I take the derivative of this, but let's just focus on this, right? You see how this is 3 times 2x, which is also just equal to 6x?
Yeah.
Yeah. As long as this doesn't have an x on it, we're okay. Multiplying factors are okay. Yeah. But good. No, it's good. It's good to catch that. Yeah, because I could have fucked this up, honestly. Yeah, and did I? I don't think I did. Oh wait, I did. I did mess something up here. Oh, thank you. Thanks for catching this. Actually, I forgot to multiply the 1 over 4 pi inside here. Okay. Nope. See, I drank too much coffee earlier. I'm getting ahead of myself. Okay, let's just do this right. Sorry. X over 8 minus 20 over pi plus x over 2 pi. Right? That's what it should be. Okay. Yeah. Now this is even. Wait. You hate it too? What do you, we have a geometry coming up? Okay, yeah. You're good. You're good, Amog. Okay. So now if I multiply everything by, oh no, but why do we have the 2 pi on there, dude? Dude, why did your teacher give you such a messy question? I don't like this. It's so messy. It's just algebra at this point, which is gross. I don't like it. All right, I got to multiply this by pi. This is by pi. I got to multiply this by 8. This is going to be 160. And then I got to multiply this by 4. Okay, good. So now we have pi x minus 160 plus 4x is equal to 0. Okay?
Mm-hmm.
Because once all these are in the denominator, I can just throw it over to the other side. Okay? All right. So 4 plus pi times x is equal to 160. So x is equal to 160 over 4 plus pi. Let's see if that's something better. 4 plus pi. Okay. That gets us 22.4 is what our thing is, okay? All right. So that means that for the square, we're going to use this. We're going to use the 22.4. And for the circle, we're going to use 40 minus that, which would have been, what's that? That's 17.6 for the circle. I believe. Yeah. What's up, Anders? Yeah. Yeah, that looks better. Yeah, multiply by the 8 pi. Yeah, yeah. Okay, good. Okay. Now you have to technically when you do these optimization questions, we should check whether this is a minimum or a maximum. And the way to check that is to check the endpoints. Does your teacher ever tell you to do that? Check the endpoints?
Not phrased that way.
Okay.
I'm not sure.
Well, so for instance, when I mean endpoints, you see like what's the, the closest I could cut it and like what's the furthest I could cut it. That's the endpoints.
Right.
It's like what are the extremes, right? My extremes are like x could equal 0 or x could equal 40, right?
Yeah.
Good. It's called the extreme value theorem in calculus. Is that what it is? Instead of the intermediate value theorem?
We never
Chat's being
learned
funny.
that.
Chat's being funny. Yeah. I don't think it's actually called the extreme value theorem. Is it? Is it a real thing? Okay. Yes. So let's assume that x was equal to 0, right? Let's assume that I cut it here, so nothing got used for the square, right? And everything was used for the circle. Then, right, we know that the area would just be equal to this. So this is just the area of a circle with using all the wire. And that would have been pi times 40 over 2 pi squared, right? Which would be, what's that? 1600 over 2. So that would equal to 800 centimeters squared. Okay? If I were to plug in for here, does that make sense, Swux, so far?
Yeah.
Good? Okay, cool. All right. And then let's assume x equals 40. So in that case, I'm not even making anything for the circle. I'm using all of it to create the square. In that case, we remember, right, that each side of the square was just going to be 10 because it's whatever the length of the wire is divided by 4. So in that case, the area of the square would be 40 divided by 4 is 10. That would be equal to 100. Okay. So that seems like a huge difference. What? 800 to 100? Don't get me started, the MBT. I actually like MBT. I think MBT is cool. Let me make sure that's right, sorry. 40 equals 2 pi r. So r is equal to 20 over pi, right? And then it's pi times r squared. Oh, wait, no, it's 20 over 2 pi. Wait. Oh, I forgot this. This is over 4. No. I'm making errors today. This is 400. That makes more sense. Okay. When I saw it was 100 to 800, I'm like, well, that's a lot. Yeah, 400. Okay, so here are our two areas, 400 and 100. Okay. So then let's look at what happens to the area if we used our equation right here, which was 22.4. So if I have 22, was that what we got? Yeah, 22.4 squared over 16 plus, and then this is pi 40 minus 22.4 over 2 pi squared. Let's see what we got. 0.4 squared divided by 16 is that 31 plus, and then it's pi times, and then it's 40 minus 22.4. You got to be careful with all the parentheses here. 22.4 divided by 2 pi. That gets us 56. Okay, cool. Nice. All right. So here's what happens, Swux. So Swux, if I were to use all of this to make the circle, the total area would be 400. If I were to use all of it to make the square, the area would be 100. And if I use this in-between amount, the 22.4, I get 56. So is 56 a max or a min of all this?
Should be a minimum.
It's a minimum. Good. So this tells me that this is the correct answer, that it is 22.4, and the enclosed area minimum would be 56. This question is crazy. I agree. It is crazy.
There's like 4 pages of questions. Like,
Yeah, dude, this one's actually a huge bitch, honestly, because, I mean, the strategy is okay. That's the main thing I want to teach you. I want to teach you the strategy, right? Of you have something, figure out what the variable is you get to modify, right? In this case, it was where do I slice this wire?
yeah.
And then figure out the equation of what you're trying to minimize, which in this case is the area of both things in terms of that variable. And then after this is just, unfortunately, brute force calculus and algebra. Yeah. I mean, if I really wanted to be, the other way to do it would have been to check the second derivative of this, but I really didn't want to. I was like, I don't want to do it. I guess it would have been positive. Yeah, it would have been positive. Actually, that wouldn't have been too bad, Penn Center. Would have been. The extreme value theorem states if you have a continuous function, then the maximal and minimal values of the function appear either at the endpoints or at the critical number. Oh, cool. It is a real thing. I like that. Isn't there also a pi in the denominator? Where? Where was the pi? Where's the pi? I think this was okay. Yeah. Okay. Yeah. Okay. All right. Let's see. Maybe your next one is not so bad, right? Let's see this one. Okay. I assume this is going to be. Oh, at the x equals 40 endpoints. Let me see. Probably. Yeah, I think this was here, right? Oh, or x equals 40. Yeah. Oh, yeah. Sorry. Yeah, this is 4 pi. Oh no. No, wait. You're so right. 4 pi squared. Yeah, it's over 4 pi. Oh, thank you, Penn Center. Yes, that's why this is even the 400 was starting to bug me. I'm like, that's a little bit too much. Yeah, no, this is 400 divided by pi. Thank you. I'm doing silly mistakes today. Good. That's 127. Okay. It's the same answer. There's Swux, but thank you, Penn Center. This makes it doesn't affect anything, but yeah, it makes it more realistic to me. I was confused. Like, bro, how is the area of the circle 4 times the area of the square? Like, I know a circle is like an infinite dimensional number of sides square, but like that's too much. Yeah, this makes more sense. Okay. Where is this? Okay. 2 towns are located on opposite side of the river, which is 100 meters wide. The company has to connect the towns with a cable. Quibble's on the north end of the. Oh my God! What are all these places? Why couldn't they use real? Is there a place called Quibble, dude? What? The fuck is Quibble?
I have no idea.
God damn it!
In my diagram, I just put Q and P.
I feel like that sounds good. Okay. Okay. All right. Here we go. Let's draw a picture. We love drawing pictures, right? Okay. Cool. All right. So we have this. We have the river. Okay. And then we know this is 100 meters wide. Quibble's on the north bank, 100. Okay. So Quibble. And then this is 1,000. This is not the scale, obviously. And then this right here is going to be Peoria. Oh, they love this question. This is actually a very good like real life question, because yeah, it costs a lot less money to put cable on over the ground versus putting cable underwater, right?
Mm-hmm.
Yeah. Okay. Cool. All right. Okay. So yeah, I think we're gonna use trig on this one, Penn Center, right? I think we are.
Yeah, this is a trig question.
Well, yeah, it's a trig one, right? Yeah. So we have to think about when connecting my cable from P to Q, what is the one thing I would change in order to vary like how I connect it? It's kind of like, right? It's the amount that I do over the water and the amount that I have it go like this, right?
Yeah.
Right? That's kind of what I see, right? I like to also consider the two extremes, right? I could either run it straight across and then I have to do this much over the land, or I could run it straight over the water and do nothing over the land. And then you want to ask yourself, Swux, like, what changed between these two things? Like, what is like one variable one parameter I could see that I'm messing with between here and here?
You're moving diagonal across.
Good. Diagonal. Yes, good. Okay. Do you see how maybe what I'm changing here is the angle?
Yeah.
Right? So the angle at which I have my... Wait a second. I need this to not be a thing. Yeah. The angle at which I attack the shore from P will vary how much of it I need to go on the other side of the shore and how much that I just need to go into the water.
Yeah.
Okay? All right. So let's use this angle as theta. Okay? All right?
Sure.
Okay, now I have to put my thinking hat on because this is tough. Because if theta is 0, it's this and this. And if theta is an angle, I like to always draw like an in-between case. So I can kind of see like what's happening. Let's use, and also there's a bunch of different ways you can do this. Let's use this as like our in-between case. Okay, I think I'm starting to see it. Okay. So in this triangle, right, we know that this is 1,000, right? Let's call this amount like x. So this would be 1,000 minus x, right?
Yeah.
Okay. And then this amount, right? This is the hypotenuse, right? Or like y. Okay. So if this was our angle theta, right? Okay. Then we see, let me see, the sine of theta is equal to x opposite over the hypotenuse, right? Okay. Is that going to help me? And then what? The tangent of theta is equal to the opposite over the adjacent. Do you see for this triangle I'm creating here?
Yeah.
This one's kind of this is kind of a mess to look at, dude. Opposite over adjacent, which is 100. Yeah, what's up, Teacup?
If we know that it's 100 meters across the water.
Good.
And it's 1,000 minus x.
Mm-hmm.
Then can't we just solve for the hypotenuse with a squared plus b squared equals c squared? We don't need an angle.
Oh, I like that. No,
'Cause
I
it's
do
a
like that.
right-angled triangle.
I like that. No, I do like that. I do like that. Yeah, we probably actually don't need trig. Yeah, let's. That's a better way to do it. Let's do that. Yes. Okay. I like that. Okay. I get it. So we can, instead of solving for theta, we can just solve for what distance do I need to hit it from directly straight across. I like that better. Yeah, we don't have to use trig. So yeah, that is, again, so what we could have done, we could modify what the angle is for it to go from here to here, or I can modify, okay, how far from directly across do I attack at? I like that. Yeah, that's much better. That's smart. Okay, good. Right. So, 100 squared plus x squared is equal to the hypotenuse squared, right? We agree with that?
Yeah.
And then, so the length diagonal, that's equal to the hypotenuse. And then, so let's call this the length over the water. And the length over the ground, that's equal to 1,000 minus x. Okay? What's up, Mikasa? You can come up. This question's crazy. It is. Okay. So then the total cost, right, is going to be equal to, what is it? It's $50 over the ground, right? So that's 50 times the amount over the ground, which is 1,000 minus x, plus 100 times the hypotenuse. Okay? What's
why
up,
don't we
Mikasa?
just do? Oh, hey, yeah. Why don't we just do 100 squared plus 1,000 squared, and that just gives the hypotenuse.
Let me think about it. 100 squared plus 1,000 squared. Oh, okay. Because that would be the hypotenuse of it going directly across, like the extreme, right? I need the hypotenuse to change based on where I'm deciding for the rope to hit on the other end of the bank, if that makes sense. So we're not solving we're not solving for this. We're solving for, okay, if I place it here versus if I place it here or versus I place it here, what is that hypotenuse? Does that make sense?
The hypotenuse
yeah.
should be as like small as possible.
Well, we don't want
Or
it to be
not quite.
there's a trade-off. There's a trade-off, right?
Yeah.
Because yes, it is expensive for it to go under the water, but I don't have to go as far. I only have to go 100 meters. The more I have it go this way, the longer distance it has to travel on the other end over the ground, which costs less per meter. But if there's a ton of length there, then it's going to end up being really expensive.
Right.
Yeah. So again, we need everything in terms of one variable, which I have x so far. The other cool thing is there's this second equation here, which relates the hypotenuse to x, which is...
So you can just sub.
You can just sub it in,
Yeah.
right? Cool. So now we have something. Now we have a differential equation because we have y is equal to, what is this, 50,000?
Okay.
I'm just gonna use a
And then would
calculator for
you-
this. Yeah.
Would you take the derivative?
Yes. Which, this is messy. Like, I don't want to do this because first of all, this is a chain rule.
Yeah.
Are you allowed to use calculators, or is she expecting you to do this by hand?
Like we're allowed a scientific calculator. Yeah.
I think you get to use a calculator for this. Yeah. Okay. Cool. I'm gonna show you
Yeah.
do this on a scientific calculator because, like, screw this, dude. So one way would be to take the derivative of this and then solve for where it's equal to 0 and then check the endpoints. The other way is to just graph this, right? And then just figure out where the max and the min is. Okay. So I graph this. This is 50, right? 1,000. 1, 2, 3. Minus 50x. And then it's plus 100 square root of 100 squared, and then this is plus x squared. Okay.
Okay.
And then before I graph this, I want to set my window correctly. Okay. So let's think about what's the minimum x can be. What's the smallest that x can be?
0.
0. Good. That's good. And then what's the maximum it can be?
1,000.
Good. 1,000. Okay. Cool. And then the cost, well, I have no clue how much this is going to cost, but I know it's not negative dollars. Let's assume, well, if it was 100 and 1,000, that's, what is that? That's a lot of money, dude. That's 50,000 plus 1,000. I think 51,000 is like the extreme. So I'm going to say 55,000 is my maximum Y. Okay. And then let's just trace this. See if it wants to graph something. No? Doesn't want to graph anything? Come on. Why is it not graphing nicely? No, nothing. Okay. Now we check our table. 0, 60,000.
We can't use a graphing calculator.
Oh, you can't use a graphing calculator?
No, we can use a scientific calculator.
No! We gotta do this by hand?
Yeah.
Bro, fuck this. Fine. It's okay. We'll do it. It's okay. All right. You have to do this. So, okay. dy dx. The graphing calculator is fun. It's cool to see how that works. Okay. And then this is plus 100. So then this I have to write as 100 squared plus x squared to the 1/2. Okay. So the derivative, this is a chain rule where I take this, I pull it down.
Yeah. And
Right.
then you get like negative.
So I get 100 squared plus x squared to the minus 1/2. And then I need to multiply by the derivative of what's inside. which is times 2x. Do we remember that from the chain rule in
Yep.
this?
Yeah.
Okay. And then I need this to be equal to 0. All right. Jesus, this is just so ugly, dude.
So like negative 50.
Yeah, right. Negative 50,000.
Plus 50 over 2 times.
Yeah, let's keep the x stuff over here. So this is minus 50x plus 50 plus 100x. Sorry, right? Because it's the 2x and the 1/2 cancel, right?
Right. Yeah. Yeah.
Plus 50x over the square root of 100 squared plus x squared.
Yeah.
Bro's hungry for some Fortnite. Yeah. Okay. Oh man, dude, this is not nice.
Original 50,000.
Oh, dude, thank you. Thank you, Mikasa, dude. Yeah, this is okay. Yeah, you're right. This is 0. Okay, because otherwise this is about to be like not separable. Thank you, Mikasa. Thank you. This is 0. Sorry, this is negative 50. Okay. Okay, now this isn't so bad. Thank you, Mikasa. I appreciate that. I got excited just doing this derivative. I forgot that these also need to be derived. Okay. 50 equals that. Awesome. Okay, the 50s go away. That's great, right? So I get 1 is equal to x over the square root of 100 squared plus x squared. Okay. So move it over. Okay, this isn't that bad. I was getting flustered. So 100 squared plus x squared is equal to x squared. Well, that's not good.
Um,
100 squared doesn't equal 0.
ew. Pain.
Pain. This is so much pain. All right, let's make sure. There's probably a minus sign wrong somewhere. Sorry. Let me see this. I mean, there could also be no critical point where this just gets more and more expensive. 100 meters wide, 1,000 meters east. Let's make sure this is right. X, 1,000 minus X. I agree. So the cost is 50 times 1,000 minus X. I agree with that. Plus the hypotenuse times 100. The hypotenuse is the square root of 100 squared plus X squared. Yes. Okay. Yeah. This is great. What's wrong then? What's wrong, Buttercup? What's going wrong here? Let me see. Let me see if there is a. I'm just gonna have Wolfram do our derivative. Make sure I didn't screw something up. Minus x plus 100 square root 100 squared plus x squared. Okay, here we go. No. Okay. Okay, this looks like there is a minimum. This is nice. There is a minimum. Okay. So let's just take the derivative of this. Let's make sure I didn't do something wrong with my derivative.
I think it might have been when you canceled out the 2's.
Mm-hmm. Well, I think I needed to still have a 50. Sorry. 50,000 minus 50x. Okay. That's that. Oh, I forgot. There's still an x here. That's the mistake. I forgot there's still an x. Okay. I think this is it.
And is that 100 x over square root of 100 squared plus x squared?
You're right as well. Good. Yep, this is 100x. So this is actually going to be what's that going to be? That's going to be 2, right? I think. Right? Because we had 50x, 100x divided by 50. Yep, this is cool, right? Okay, 1 second. This is all wrong. X squared is equal to 4x squared over 100 squared plus x squared, right?
Right.
I think so. Let's double check this. I don't. I'm tired of making silly mistakes today. I'm just
There's
like
so
annoyed.
much room for them.
I know that's the problem. Yes. Okay. Good. Right. X squared. Yeah. It's the extra 2. Yeah. Okay. Cool. Oh. Okay. So this is 100 squared plus x squared is equal to 4, right? Because the x squareds go away. Then I can move this over. Okay. I don't like this. This is already like way too small.
That's gonna give you a negative solution, right?
I mean, here's the analytic solution. I could say here. Say equal 1 equals 0.
A
That should-
negative square root.
Let me see. Oh, this says 100 over square root of 3 is the solution. Wait. No. This is what I want. Oh, yeah. This says it's going to be 100 divided by the square root of 3. Okay. So let's see where we messed up here. Where do you see something, Mikasa? Did I do something wrong?
Minus 50x.
Yeah.
It should just be minus 50.
Correct. Okay. Oh, okay. That's what Penn Center was saying. So sorry. I'm making double mistakes on
Let's see
things.
if that works.
I think that works. I think it does. Okay. 50 is equal to 100x over the square root of 100 squared. Yep, thanks for that. Yep. Okay. Now I think I should square both sides, right?
Yeah.
Equals 100 squared x squared over 100 squared plus x squared, right? I just don't like all these math.
500 equals 1. Oh, no. I misread.
Yeah, no, it's dude, there's so many numbers on this, dude. Oh my god. Here, let me leave everything as like squareds and maybe things will look nicer. 50 squared, 100 squared plus 50 squared x squared is equal to 100 squared x squared. Okay. Okay. 50 squared 100 squared is equal to 100 squared minus 50 squared x squared. Yeah?
Yeah.
So x squared is equal to 50 squared 100 squared all over 100 squared minus 50 squared. And then I'm going to square root both sides. But I get a calculator for this part at least, damn it, right? Okay. 1 sec, not that. Okay, where's my calculator? There you go. Okay. Oh my god, dude. Well, at least the 50 and the 100 squared over this, at least this goes away, which is nice. At least that's 50 times 100 over the square root of 100 squared over 50 minus 50 squared. Dude, why so much pain with these numbers, dude? Oh man. Okay, good. Divided by, and then what is that? Yeah,
Squared
square.
minus 50 squared.
Which I wish that was something nice, right? Why can't I have like a 345 in here or something? Like, come on. This is poor engineering of a question. Okay. So that's 57.73. Which I don't think is exactly what Wolfram got, though. Wolfram got what? 100 divided by the square root of 3? Oh, maybe that is right. Right? What's 100 divided by the square root of 3? Yeah, 57.73. Oh my god, Jesus Christ. Good. Okay, I'm not even going to see if that's a max or a min. I'm just going to assume it's a fucking minimum. But yeah, I mean, technically, I guess you could take another derivative, but ew, I would not want to do that. You should check the endpoints, like Penn Center said. That's what you should do. Yes. I'm dying eternally. Yeah, I'm dying eternally, dude. Look at all this like garbage ass math I had to do. What? Okay. All right. The main thing here is the setup. Swux, I hope that you get the setup. The setup's the most important thing. Fuck all the bullshit algebra and shit you gotta do. Fuck that, dude. Like, I don't understand that, dude. Why? It doesn't teach you anything. It just makes me frustrated.
Busy work.
It is busy work, dude. What? Like, what do we, this is where, people start yelling about ChatGPT is like ruining whatever and stuff. And I'm like, this is kind of ruining whatever, man. Like, why would I do all this busy work when I could have, you should be able to use Wolfram to eventually just say, hey, just solve this. Like, I don't need to prove to you that I know how to do algebra. Like, I know how to do algebra.
What level is this?
Yeah, what level is this?
Well-
Yeah, Mikasa's asking a good question.
I'm in Canada, and this is for a course called Pre-Calc 12, Calc 12 combo.
Oh, okay.
So it's like
that
an
also
introductory
a-
calc thing.
Is it a college course or is it a high school course?
This is a high school course.
Oh, wow. Pensinder said, "Does someone say Canada?" We do have a lot of Canadians, in this Discord in the stream. Yeah, we do have a lot of Canadians. Yeah.
I think,
It is interesting.
yeah. It's not like AP or anything. It's just,
Yeah, I remember doing something similar to this, but it was definitely not as hard.
Yeah, definitely not as hard, dude. This is kind of nuts. Mikasa, are you in Canada? I forget. Where are you from again?
No, I'm from the UK.
Oh, the UK. We got another UK enjoyer. Do you know Sensation, right? Sensation Black. He's also from the UK. And then
It's 1 AM here.
yeah, it is late. Yeah, well, yeah. Where Sensation? Where are you at? Sensation, come to the stage. Come say hi to one of your fellow Brits.
yeah. See as well.
Yeah. What's up, Sensation? Your mic is still muted. Man, who did I give this to? This is Swaz. All right, nice. Okay, good job, Swux. Yeah, if you have any other questions like that, I enjoyed these as much as they were painful. I hope they make more sense to you.
Well,
And
I
then-
have like 16 of these.
Okay,
So-
I will pray for you. I will fucking pray for you, dog. If you need help with the setup, like I'm happy to help. Or if you want to like just say like, hey, did I set this up right? That's great. Send that to me.
Sure.
In terms of the algebra, you're on your own, dude. Like whatever.
Okay.
you
Well,
can
thanks
do
a
it.
lot, man.
Yeah, you're welcome. You're welcome, dude. All right, nice. Oh man, math is greater
Hello,
than
Brett.
geography.
I'm from. You do realize I'm from North, right?
You're from the north. Where's from Mikasa from? What part of the UK is Mikasa from?
Sounds like he's from the southeast-ish.
From London.
You can tell the
London.
accents.
Yeah, sort of.
He's from London. Wow, you can tell the accents. Oh, that's cool. I'm like, y'all just sound like British people to me.
Yeah.
You sound like my mother. My mother's from Cambridge, so like I have a lot of, and I'm just like, it just sounds like British people. Oh man.
Sorry, guys. Would you rather me talk like this? And then you
There
can
you
know where
go.
I'm from, didn't you?
Then I think you're from like Scotland, which you basically are. Like North England is basically Scotland, even though I know they'll get mad if you say that.
Anything fun?
Anything fun? High page. I don't know. We just went through a bunch of like shoot me like algebra. I was just like, no, dude. I was about to murder myself. But it was cool. I like the setup of those questions. The setup was cool. I wonder actually, Mikasa, would we have had nicer? I don't think we would have had any nicer stuff if we had used like sine and cosine. Probably not, right? Like to find the angle, that would kind of suck.
It's funny what Penn just said.
What did Penn just say? I always get Sensation mixed up with the Scottish. Yeah, right? Sensation does sound kind of Scottish.
That's because I am Scottish, yeah, prick.
Yeah, prick. We might have a fun one here. It's geometry. Let's see. Jamarcus is asking about parallelograms. Oh my god. Oh, fucking kill me, dude. What? All right. What's up, Jamarcus? Or a convex quadrilateral inscribed in a circle. What's up, Hypatia? What were you gonna say?
Yeah, I was thinking about, do you know, like, the fan word, like, the generalization of parallelogram? Do you know how it's called?
I don't know.
Center might know. It's called
What's a generalization?
parallelepiped.
Parallelepiped. That's a thing.
Yeah.
Dude, I'm learning all these new words every day, dude. I love it.
The other day, Penn Center was streaming like pronouncing how to pronounce French words, and then also
Parallelepiped. Parallelepiped.
Yeah.
It sounds like, yeah, that's a tongue twister. That's a cool shape. Oh, this is the cool thing where isn't the cross product of A and B like times 1/2 the volume of this thing?
Yeah, and then there's like
Yeah.
a like n-dimensional generalization of it. Although I don't remember how it's called.
Yeah. Oh, this is super wicked.
Wait, maybe.
Oh man. Yeah, this is. Oh, I remember doing this. This is actually some cool stuff. I forget why this works. We should do something with it at some point.
Like the tensor product, the triple product. Triple product is actually really fun. It's like
The triple
among
scalar
all
product? Is it the triple scalar
Yeah.
product? Yeah.
Among all Euclidean spaces, only 3 and 6 dimension has triple products.
Interesting. 3 or 6. Why not 9? Why do we stop at 6?
I don't know. I mean, it might be related to. I sincerely don't know. Like dimensional specificity, like in A dimension, there's another thing called exceptional lattice, which is
Yes.
the Ukrainian mathematician. Yeah, you know that you're a physicist. Yeah.
I've heard about the exceptional stuff before. I'm like, wow, exceptional math. That's dope. Let's see. Jamarcus, which one did you? What did you say, Jamarcus? Sorry, you were in the chat way above. Let me see. What did you say? You have a test tomorrow or something? What was going on, Jamarcus? Ping me on Discord. I'm gonna go take some notes. I don't understand. Okay, there we go. Okay, we have geometry coming up today. Okay, yeah, cool. Man, do I want to do the quadrilateral inscribed in the circle, or do I want to do the parallelogram? Both are painful. I think I want to do the parallelogram. Yeah, let's do this. Yeah, let's do this. I want to do this one. Pain has begun. Jamarcus takes like an extracurricular. He's only in like 8th grade, I think, but he takes this thing amongst these. It's called like the Russian School for Math. What do they call your thing, Jamarcus? What's it called, dog? The Russian School for Math. Of math. Is it like this? Oh, you're in 7th grade. Oh wow. Yeah, here we go. Russian School of Mathematics. It's like an after school club for learning how to get really good at math, but I guess they use the Russian method, which right, it's the whole thing. I was like, what's their method, dude? Is it like murdering innocent like civilians in the Ukraine? What's the Russian method of math?
No, it's mentioning it probably about Arnold's pedagogy. Like I told you about this, the Independent University of Moscow and HSE. Now it's called Higher School of Mathematics. Basically, like people like this, like the people don't lecture. Like you just give out problems and have one-on-one discussions.
Oh,
If you
okay.
want to- I might have already told you this. You can try to Google Moscow State School 57. That's like a lot of brilliant mathematicians. Before they were IMO medalists, and then like this bunch of really great people coming out of that school.
I get it. So it's the typical. I had this even when I was learning cello from my teacher, he was from Romania, and he talked about during like Soviet occupation and whatnot that you had 2 choices. It was either practice all these etudes and get really good at them and go to conservatory, or get conscripted into the army. So you basically
that's horrible.
you give these people all these like really ridiculously hard challenges, and eventually they kind of like build themselves up, which. I mean, I agree that doing questions is a good way to learn, but I think teaching is also important.
Point. The thing I appreciate about this Russian method is not, of course, not the forcing people or atrocious part, but
Yeah.
Just a different, like a flip classroom. Have you heard of like those kind of things? It's
Flip?
also like when Zach was teaching the analysis course. It's very similar,
Oh, where the
actually, to
students
the-
work through things, and then the teacher's kind of more just a guidance. Yeah, I like that. It's almost like Socratic education, right? Where the students are asking the questions.
I describe my stream as dialectic. But,
Dialectic. I like that. That's cool. All right, let's try to do this one, Jamarcus. Okay, ABCD is a parallelogram. G what's this? G something. What does this symbol mean? Does anyone know what this means?
In the element of.
What is it?
I think it means in the element of.
Oh, okay.
No,
G.
I don't
Oh,
know
G is no. I like that. Yeah. G is somewhere along segment AD. E is somewhere along AB. Okay, I got it. Cool. Yeah, that makes sense. EF is parallel to AD. Okay, I agree with that. Cool. Whatever we'll say. Yeah. All right. AE to EB is 2 to 3. So this to this. Okay, so this is 2 to 3. Okay, I understand that. Area of BEH is S1. Dude, why are we naming so many things, man? What? Area of ICF is S2. Find the area of GHI in terms of SI and S2. Okay, cool. So they want the area of this in terms of these two things. Uh-huh. Do we have any first idea, boys? Do you have an idea like how we start this one? I see maybe some similar triangles. I know that this angle equals this angle, right? I'm just gonna say these things just to start, you know. Oh, and if it's a parallelogram, right? That means that all these sides are parallel, right? Okay. Maybe we can use something with a transversal here.
I mean, try to draw a line that's wait.
That means this is also 3 to 2 as well, right? If this is 3 to 2, this must be 3 to 2 since this is parallel.
Yeah, try to draw a
yeah.
parallel line to C and D, like passing through G.
Okay.
Like the parallel to like that, and try. I guess try if you can see anything out of it. I'm not quite sure.
I see what you're trying to say. You're trying to say like maybe this is like some sort of transversal. Okay. Oh, okay. Well, then this angle, right? This angle must equal this angle, right?
Yeah, but it doesn't solve the immediate problem. What else can we try?
1 sec. Wait. Okay, but then okay. No. I think I'm starting to see something. I want to build like a similar triangle. That's what I want to do. I see that like this angle, right, must be equal to this angle, right?
That one doesn't work. How about no, that one doesn't work either.
Dun, 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 dun. Oh, and then these angles are the same. I'm running out of like angle things that are different. This angle is the same as no, this angle is 180 minus this angle, right? 180 minus this. Oh man. And then we need like a base and a height, I think. Oh my god, dude, what? It's got to be something with proportions. I agree. I want similar triangles is what I want, I think. Because then I can start doing something with the 3s and the 2s.
Well, you don't have to in this sense. Wait, no, not that. I mean, you can try to find right angles as well, but you don't get any.
Yeah, and also everything's like diagonal, so right angles start becoming tricky. We love geometry. Absolutely love geometry. We love geometry, guys. Okay, wait a minute. This triangle is inscribed within this one, right? If I were to call this like, yeah, I get confused on whether I want to start trying to make right angles because I eventually want to get some areas. I need some bases and some heights. But this is one of these things where I'm sure there's some like weird property of triangles that I don't need to do that.
Wait, actually try to draw a similar parallel line but passing through I instead of G.
Okay,
Like parallel to CD.
like this.
Yeah, so let me think. Now you can have a small triangle for like
We have this. Is
uh
that what you're talking about?
no, not that one. The IDF. No, IDF. Well, the triangle IDF.
Oh, this?
Yeah, so let's think. However you drag that I, or by changing the angle of the parallelogram, the wait. Now the height
You mean
yeah,
if I were to
so
move, if
so
I were to
that
move this way?
IDF like the IDF is the area is just S2 divided by 3 times 2. I think that's how it works, right?
Oh, you're saying that this? Let's call this like S4 for instance. You're saying
Yeah,
S4 is equal
S4
to S2.
over 3,
Okay.
entire thing times 2.
Oh, so times 2/3.
Yeah.
Oh, interesting. Why do we know that?
Because you can like
What's up, Enigma?
it's a like these two triangles, they have the same height, and then their base is 2 to 3 ratio. Does that make sense?
How do we know that these have the same height? This isn't 90 degrees.
Yeah, but you can draw a 90 degrees thing between the two lines, between the purple
Because they're
and
both
the
purple. Okay, I get it, because they're both
they're
perpendicular.
parallel.
Good, they're
So
parallel.
you can
Yes.
drag I along the parallel line, and that
Right.
without changing its area.
Okay, I like that. Okay, so if triangles have good. If they have the same height, then the areas is the ratio of their bases.
Do the similar thing with H, with point H.
Okay, let's try it with H. I like that. Okay, let's do this. So we want to do something like that.
And the AH.
And then AH, you want to do this?
Yeah, I think then you can do a similar thing as we did there, but
Okay, let's call this like
does
S5.
solve our problem?
So this is what's saying S5 over 2 is equal to S1 over 3.
Yeah.
Okay. I like this. This is getting closer. Okay.
So now, do we know, like, is G
Oh, and
a
this cuts it in
free
half.
thing?
This cuts it in half, right? This cuts the this shape, right, in half.
Yeah.
Good.
Yeah, and then the other side as well, but it doesn't.
Okay.
I
But
don't know if we
then what about
use that.
these? Yeah, what about these, right?
Do we know anything about, like, can you show the full the full problem? Do we know anything about the G? We don't.
It would be nice if we knew if we knew okay, because I know the area of this. I know the area of this, which means I know the area of this, which means I know the area of this. Oh. Wait, and I also know the area of this, right? And then I know the area of this.
Yeah, you know all of them.
Okay, so we know all of this. We know all of this. We're trying to figure out
Yeah.
this. So the last thing I need to do is probably figure out this, right?
Yeah. Let's show the full problem. Let me see the full problem that if I have anything.
Okay. No, I like this. This is getting good. We're moving in a positive direction here.
B H, so we're BH, so you know that one. And then that's parallel to the. No, there's nothing else. Then let me see. What can you do?
Mm, mm. Maybe there's something with. Yeah, man. I mean, all I need is. Oh, no, let's not move that. I need these 2 volumes, and I need this. But okay, but then, yeah, I need the rest of these volumes, in terms of one of these things, the S1, S2, and S3.
Yeah. I mean, wait.
Okay, well, wait a minute. I know that this length is 3, right? And I know that this length is 2, Hypatia, right?
Yeah.
So, I mean, all I kind of need is this, right?
I mean, if you know the entire thing, then
Yes,
this
if I
might
knew
work.
the whole thing, this would be nice. This would be cake if I knew this, but I don't, right?
Well, what doesn't change in the meantime? I mean, what if? No, it doesn't do like that as well, but that doesn't work.
This triangle is inscribed within this triangle, maybe?
Well, it's similar, but you don't know how.
Yeah, I don't know this is
Uh,
the issue, right? Also, yeah, that doesn't give me a doesn't give me a it doesn't give me an altitude I need in order to get the area.
What if? I mean, that doesn't work. If you set, let's say, AG as a with
A
a
variable?
variable, and
Let's do
then
it.
try to derive something from it, I mean,
So let's call this like x, for instance. Let's call ag equal to x.
yeah,
Okay.
use a Greek letter. Don't use X because you
Epsilon?
might label.
Oh, epsilon. Epsilon. Okay. Okay. So I know 5 over epsilon, right? 5 to epsilon has to be equal to 2 over whatever this is, right?
I don't think it will work.
Yeah, that doesn't help me with anything, right?
What else can you do?
What if we relate it to this, maybe?
Wait.
5 to epsilon is... I'm just going to call these different things. I'm going to call this alpha. I'm going to call this beta. Okay. No, but see, I don't want to go this route because the issue becomes...
Yeah,
I'm gonna have to find these in order to do these,
yeah.
and I don't want to do those. I really don't. I liked your method of this. This is very clever doing this, making this proportional to this, because they have the same height. I think that's the way to go with it.
That's dragging thing. It's a wait.
Is there something we can form with this triangle? Can we do something with these?
But well, then do you know EH and HI? I mean,
Yeah, that's the issue. Yeah, I know these
oh wait,
these all
are
add
they
up to some.
1 to 1? Like EH and HI, are they 1 to 1? I mean, that's a like try to see if you can
Yeah, like
prove
yeah. If
using
I
the
dragged this
using
way,
the
I see what you're saying. I see. Like if I do this, right?
I
Are we saying
feel like
that this is equal to this?
probably not.
It'd be kind of cool if it was.
Oh no, that probably won't work either. Hmm.
Do you see why these questions like frustrate me? And the terrible thing is he doesn't get solutions on these. Like they just get given out.
Yeah, it's like an Olympiad kind of training question. I mean,
Yeah,
well,
but
Olympiad.
there's
IMO loves circles. IMO is not usually about triangles.
you're not about triangles, you're a circles person.
Yeah, I remember that one really clearly. Like Olympiads, they like circles, so many circles.
He had a circle question. Maybe we can do that next time.
Wow.
There was something with it was a quadrilateral inscribed in a circle. Yeah,
Hmm.
Jamarcus, we're close on this one. I like Hypatia has some really good ideas about. We have all of these areas,
If
which is
Tencent
nice.
still there, maybe call them and
Yeah.
ask if they have anything.
Yeah, I think the issue is, you know what? I'll send this. I'll send this to either Brian or Zach. I'll send it to their stream. I want to end it all. Yeah, it's something weird. We have to figure out this is what we have to do, and then we have to figure out this and figure out this. That's all we have to do.
I mean, you can try to. There are Euclidean geometry solvers. I mean, I think even GeoGebra has something similar to that, but you can
Where
get
you
an
can
answer
define
from
this,
it.
you could define
Yeah,
the
like you will be able to get a guess on the answer, and then you can try to reverse engineer the process. But it's a long shot. It's the last resort.
I think this is probably equal to this. It would be nice if it is, right?
Whoa.
Or BEH and BAG proportional. BEH, so you're talking about this, and BAG. Yeah, well, they're similar. Yeah, we knew that. We know they're similar triangles. But the problem is, like, we don't know this, and we don't know this.
Wait.
Wait. Yeah,
Yeah,
what if we use this and this to then prove this and this?
No. I was talking about a similar thing. You were talking about BEH and the IHG. They are similar, right?
No,
Or
not
it's
IHA,
not.
no, and BAG. Okay, here I'm gonna call this alpha. I'm gonna call this beta. I'm gonna call this Charlie, whatever. Well, no, I can't use that. Sorry. What are like 3 Greek things? Alpha, beta, epsilon. Okay, all right. So 3 over alpha, right, is equal to 5 over AG. And then 3 over epsilon is equal to 5 over GD, right? And then alpha plus beta plus epsilon is equal to AG plus GD, right? So all of these together has to be equal to this. Hikaru, yeah, I'm busy, Hikaru. Just give me a second. Type if you want to say something, Hikaru. It's all right. All right. Can we use this to then make some inference about beta, right? Because beta is this subtracted from these two things. So let's look at that. So beta, right, is equal to AG plus GD minus alpha minus epsilon. And then here I get that alpha is equal to 3/5 AG. And epsilon is equal to 3/5 GD. Okay. So beta is equal to AG plus GD minus 3/5 AG minus 3/5 GD. So beta
Wait. I think I got something. So like scroll up a little bit after you finish writing. I
Okay.
think I got
All right, let me
something.
see. Let me see. Okay, cool.
So, try to do this. So, like, well, you didn't label that that point, but so, uh,
What point? What
like
do you label?
like you labeled the AG into a like epsilon. You said, right?
Yeah. I measured this as something in terms of epsilon, right? Yeah.
Yeah. So, let's try if to see if we can represent the sum the sum of the area of the triangle HG and then that unnumbered that not numbered that not labeled no below
This one.
like this one, yeah.
Okay.
So this one and the right one like IG something.
Oh, this one and this one.
IG something. Yeah. So let's see if you can use S1, S2, and then also the ratio to represent the sum of these two, of the area of these two triangles.
Hmm.
And you can introduce a variable representing the like the ratio of AG to AD, but I don't think you will need that. Like at the end, it probably will be. It doesn't matter.
Okay.
It will
So
be independent.
I know this is S5. I know this is S4. Are we talking about maybe like this triangle to this whole triangle eventually?
Wait.
Right? So if I'm trying to relate the
Well, those
areas,
two are similar as well, but
so these have the same heights. They have different bases, right?
so just like label the like the H line, like label that point. Label that point with something like H down, go down.
Okay. This.
Like the label that point, like the intersection.
Oh, right here.
Yeah.
Okay.
So let's represent the ratio of
Let's call it J. I'm running out of letters.
yeah. Let's represent the ratio of AJ to AG as something. And then
Okay.
now you can start representing the
AJ over AG.
yeah. So now you can represent one of the red triangles. Because we already know what S5 is, right?
Oh, yes. Okay. Ah, I like this. Or you mean in terms of JG, I guess, right? Are you saying I can relate this one to this one?
By introducing a variable representing the ratio AJ to JG or AJ to AG, it doesn't matter. It's a yeah.
Yeah, let me do AJ to JG. I think that makes more sense to me.
Yeah.
Like this one to this one, right? Okay.
Yeah.
So AJ to JG is the same thing as S5 over, let's call this S6. Right?
Now let's think about the other triangle. Can we use that ratio to do anything about it?
This one right here, S7.
Yeah. Yeah.
So that would be, let's call this K. That would be KD over GK is equal to S4 over F7. Yo, what's up? Good to see you, Zach. Yo, we're doing your favorites, dude. Triangles. Yes, shout out to...
Yeah, I hate this.
I know. I think I did this right. Let me see. There you go. There you go. There's Zach. Yo, you have to depart for dinner? Okay. We have S5, right? We have S4. This gives me S7, but now we have more distances that I don't really know, right?
No, you don't want to introduce two variables. You
I don't want
only
to start putting more
introduce
variables in
one.
here.
Because all those variables, they are the same. They are connected to each other. They depend on each other. So you only want to introduce one of them. Because G is the only point that's moving.
That's right. You're right. I see what you're saying. So that's just in terms of this. Yeah, wherever G is.
Uh,
Yeah, but then how do I get this based on this? Oh, man. Because what this is AJ plus JG plus GK plus KD. Oh, man. Ugh. Okay, I'm going to maybe like cap this because I'm getting tired.
wait. Like represent AG to GD
Okay.
as a variable.
AJ over... So AG over GD, is that what you said? Sorry?
AG to GD.
Okay. You want me to just call that...
erase the previous ratios, and I think this one can work in.
So we don't want any of this stuff?
Yeah.
So I'm going to have to erase this.
So the entire thing. No, it doesn't. You don't have the entire thing. Like
Yeah, that's the problem. We don't have this length. Yeah, that's the whole issue.
I have a suspicion that 2s1 plus 2s5, 2s2 plus 2s4, those two ratios are connected to the ratio I just wrote, but I don't know how to prove it.
I think I know what you're talking about. Yeah, I'm gonna call this right. This is 7.
It-
Yeah, you're saying this to this is
Yeah.
related to this to this.
Yeah.
Hmm.
You don't know how it's related.
Wait. Hypatia, these have the same base. What if we looked at them like these
Yeah.
triangles? These triangles? Right, don't these triangles have
Yeah.
the same base?
Yeah. Yes.
Okay.
And I mean, you
Just different
still
heights.
Don't know. Yeah, but you don't know the ratio between the heights.
Okay, S1 plus S5 over 5, right? Has to equal S2 plus S4 over 5, right? Okay. Yeah, that relates to that. Oh, that tells me. Oh, interesting. Okay, wait. These things have the same bases, though, Hypatia, right?
Yeah, but
But they have different heights.
the heights are controlled by the ratio I just talked about. But
Okay, so S1 plus 2S5 plus S6 over AG, right?
Yeah.
Has to equal S2 plus 2S4 plus S7 over GD, right? And that's our ratio we were talking about?
Yeah, it still doesn't give us the.
Gets me that to that, right?
I mean, at this point, just do it analytically. I don't think this will be extra.
Oh, it's so close. Paige is like, fuck. I know. I'm on the same page with you, man. I am 100% on the same page with you. Oh, it's so close because, like, we're just missing like one of these sides. This is what I hate. It's what I hate about geometry. It's a puzzle, and I'm so close. There's one little piece I don't know, and if I could find that one piece, everything else would just go click, 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 click. Yeah. Man, we were so close on this one. Because here's like my AG and my GD again. Here's my AG, my GD again. Right?
The thing is that you need to establish what's the
Oh, you know what's easy?
like-
And no, Hypatia, this is because once we have S7 and S6, right?
yeah.
Then I have the volume of this. What I'm looking for is S6 plus S7, right? Right?
What if you can try to prove
This is it. This is what we're looking. We're looking for these two things, okay? We're given. I know these. We just need a relationship between AG and GD. That's all we need. Dude, anyone could be struggling on this one, dude. What monkey? Dude, this is nightmare level hard, dude. This is so hard. I don't know why a 7th grader is getting asked this question. I just need a
like, the
relationship from AG to
similarity
GD.
you originally proposed? So were you able to find? Were you able to use that similarity to derive the ratio of AJ to JG as depending on the ratio AG to GD?
Oh, okay. You're saying from this to this, from this and this, from AG and GD.
Yeah.
Ooh, I like that.
You were talking about there are similarities between the smaller and large triangles that might help. I mean,
Uh-huh. Well, I had this, right? So alpha, that's AJ, is 3/5 AG. Okay, I know what this is. This is 3/5.
Wait. Like the ratio of AJ to JG.
It's alpha to it's alpha to epsilon, right? Oh, it's the same thing. No.
Like, because those smaller two right triangles are all similar to the bigger ones. You saw it?
Which one? Sorry.
The two red triangles.
These, yes.
Yeah, they are all similar to the larger ones.
Yes.
Can you do anything with that? I mean, because like, yeah, it basically tells you that AG to GD equals to JG to GK,
Okay. Yes.
isn't it?
Oh,
And then
AG
what
to
can you do?
GD is J key to this. Okay.
Yeah, because they are similar. Like the smaller two red triangles are
Okay.
the bigger ones.
AG to JG or AG to GD is equal to JG to GK. Right?
Yeah.
Okay.
You see how this is proven, right?
Yeah, I know I see it. I see it's that to that, and then it's that.
exploit this.
Can I do something with this?
Yes, exactly. You can.
Okay, tell
I
me.
see it. Like the bigger one and the smaller one, like the two parallel like this, like the parallelepiped B, A, G, and then the upper point.
Like this?
Yeah, like, and the smaller one J, G, and then go up.
Oh,
No, the parallelogram, like not that the
sorry. I know what you're talking about. Sorry, this?
no, like BAG, and then the intersection between the pink and the upper black line.
Oh, okay. Sorry. This one.
This one.
Yes.
So this one to like the rest of it.
Yeah.
That's the same as the smaller, the narrower two parallelograms. Like they are of like because we just see the larger ratio, or the ratio of the larger two sides is the same as the ratio of the smaller two sides.
Okay.
And then what? I mean,
Uh,
now we can say now we can say the larger one minus the smaller one, which is basically saying
this, right?
yeah, and then we know this larger what the larger one minus smaller one is already, right?
Do we?
Yeah, we do. The S1, S2, and then all those we know those already.
Oh, okay. Wait, one second. You're talking about. I almost see it, dude. I'm so close. AG to GD is JG to GK.
Oh, wow. This is so hard.
JG. Oh, wait a minute. Wait. I think I might see something. One second. Okay. This is true, right? AJ over JD is equal to JG over JK, right? AG.
So basically now you
I think we can use this.
you-
We can use this. I think we can use this.
So basically now S1 and S2, the ratio between them is the ratio between AG and GD. Now you basically prove that.
Right? Did we prove
Yeah,
that?
but yeah, we did, but it doesn't really give you anything.
Wait, no. AG over GD, we're saying is S1 over S2.
Yeah.
I like that. No, I think that helps us. Okay. So let me rearrange this. Okay. So this is AG over GD is equal to S1 plus 2S5 plus S6 over S2 plus 2S4 plus S7. And we said this was also equal to S1 over S2?
No, what you want is to derive like what's the ratio between AJ and JG. Like is
I think all I need to get here is S6 plus S7, right? Because I know what everything else is. I know what
Yeah.
S5 and S4 are, right? They're related this way,
Yeah.
right? I know S1 plus S5 is the same as S1 plus as S2 plus S4. Here, let me try to rearrange this for S6. I think I'll see it. One sec. S2 S1 plus 2 S5 S2 plus S2 S6 is equal to S2 S1. Things are going to cancel. Plus 2 S1 S4 plus S1 S7. Okay. S2 S1 goes away. Fuck. I'm so close. And what do we know about 1 and 4? Oh, one second. I can pull an S2 out of here. No, I don't want to do that. I want to group 1 with 5. 1 with 5. Let's group 1 with 5. 1 with 5. No. Okay. S4 over 2 is equal to S2 over 3. And, okay, S5 over 2 is equal to S1 over 3. Let's see if that helps. I want 6 and 7s. I just want 6s and 7s. I want this and I want this. So I need to get rid of 1, 2, 4, 5 somehow. Two S5 times 3/2 S4 plus S2 S6 equals 2S1 we can keep the S4s, okay. Plus S1 S7. Oh, okay, wait. But then S5 is equal to 2S1 over 3. S1 over 3. Okay. Ooh, okay. This goes away. This goes away. I get S1 S4 plus S2 S6 is equal to 2S1 S4 plus S1 S7. Ooh. Maybe. Let's move this over. Let's move this over, right? S2 S6 minus S1 S7 is equal to S1 S4. Is there a relationship between S4 and S6? Where S4 and S6 they both have the same heights, but then what's this difference in their bases? Black. Ah! I don't know. I think we've worked on this one for a whole hour. I have to give up on it. It's so hard.
Don't worry, you tried.
We did. We tried so much. If anyone wants to solve this one, please. I'm gonna post it here.
Can you give me a screenshot of that question again?
I'm sending it to you right now.
Like when tomorrow I wake up and have a sharper mind, I can try again.
Yeah, if someone wants to try to solve this one was brutally hard. I still can't get it. We're close. We're so close. Yeah. What's up, Ethan? I'll give Jamarcus a credit for fucking stumping me and Hypatia for an hour. I'm gonna give that to fucking Zach or Brian, dude. I'm gonna make them do it. Or maybe I should put a ban on Jamarcus asking geometry questions. Because they frustrate me to no end. It's just, dude, like I feel like that crazy guy from what's that thing called? It's what's it? Images. It's Always Sunny Conspiracy. Yeah, dude. This is what I feel like. I feel like this guy. Like just like cracked out, just drawing triangles everywhere, trying to figure out what this is. So, if any of you like absolutely love geometry and want a challenge, yeah, please go at it. This
Can
stuff
you
hurts.
DM it to me so that I don't forget? Otherwise, these messages will be flushed out
Yes,
very
I agree,
quickly.
Hypatia. I will do that for you right now. There you go. Sent you DM. Sent ya the
I'm going
DM.
to try using some technological solutions to it.
I'd love to see it. I'd love to see it. Yeah, let's do it next time. I'm down. All right, Ethan, let me do your last question, and then let's wrap it up because I've already been streaming for like 2 hours. I'm tired.
What happened to the other one? There was someone else before me.
Was there? I didn't see anybody. Who else was there before you?
There.
Oh, I already did Swux. You know, I did him
Oh.
earlier. Yeah, he used the first question I did.
Okay.
Okay. My brain feels like it's been fried on a, I don't know, something, like a sidewalk for an hour. I appreciate that, Hypatia. We got really close. Like, I had some epiphany moments with you for a bit, which was really cool.
I'm going to try to see if I can use a automatic proof search for Euclidean geometry.
Okay. Yeah, let's find the chat GPT to solve this bitch. God
Not
damn it, dude.
ChatGPT. This one doesn't hallucinate.
This one doesn't
It's based on
hallucinate.
rigorous- Yeah, it's rigorous foundations. If it can solve it can solve it right.
Awesome. I'm curious. I love seeing the formal explanations and tech used on things. I think it's cool. Okay. This is more geometry. Damn, y'all putting me through the fucking ringer with geometry.
Yeah. This is trigonometry.
No, it's
See,
it's geometry and trig, but yeah, it's a lot of geometry. Okay.
Hey, come on, trigonometry. You hear the word geometry in there?
I do. It makes me sad.
Also, so this is actually especially this is like trigonometry too.
Okay, that's okay. All right, calculate the length QR. Calculate angle PRS. Okay. 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 Da 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 da. Yeah. Okay. Well. I think there's something where like this angle is half of this angle. Is that correct? I feel like it is. Or is it not? I gotta look up some things with triangles.
Really, your brain's already hurt like that much?
Yeah, I'm fucking zonk, dog. That last question, Jamarcus, like hurt me. This is what I need. I want this.
Seriously, you really gonna solve his very hard questions?
I'm trying. I got close.
Again, we're looking at these theorems.
Yes, I need because this is all geometry is, dude. It's a bunch of random fucking theorems about things. Okay. Oh, but this doesn't go through a radius. I don't like that. Inscribed angles subtended by the same are okay. What about inscribed and outscribed? What about the outscribed ones too? What about that one, dog? Like, does this do the same as this? We don't know. Oh, I do see something here though, Ethan. You see how this side is the same as this side? What does that mean? What type of triangle is this? See how PQ is the same length as PR? What does that mean?
It's an equilateral triangle.
No. It's an isosceles.
What? So
Yes.
what? Equilateral means that all three sides are the same, right?
Correct. That only happens when one of the angles is 60 and the other one's 60. This is 65. These are the same length, so the opposite angles to it are the same angle, okay? Which tells me what this is. That tells me this is 50. Okay. So they want the length of QR. Cool. I'm going to use law of sines.
Your sine.
Yes.
symbol.
Sine 65 degrees over 2.7 is equal to the sine of 50 degrees over QR. Cool. I can figure that out. Where's my calculator? Where'd you go? Okay, so let's make sure we're in the right mode. Degree, good, cool. Sine 50 equals that. Divided by 2.7 divided by the sine of 65. I believe. Wait. No. I have that wrong.
No, that's go. Hold on.
I
I
have that
feel
wrong.
like you're doing this wrong for sure.
No, I did the whatever. Okay. It's that times 2.7 divided by the sine of 65. Okay. There we go. 2.28. QR is equal to 2.28.
What about angle P to Q to S?
P to R to S, you mean?
Oh yeah, P to R to S. Yes, yes.
Yes, we do need to figure that out. Okay, so we got this. That's cool. Okay, now I need to find PRS. You find this angle. Ooh. Ooh, 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 ooh.
Wait, hold on. Aren't those two supposed to be the same? Like angle P and angle R?
Which angle P and which angle R?
Oh, sorry. Never mind. They're not the same side.
They're not. Okay, I can use law of cosines because I have all three sides of a triangle here. See, I have everything
True.
here. So I can find PRS here using the law of cosines, which is going to say that 6 squared is equal to 2.7 squared plus 7 squared plus 2 times 2 times 7 times 2.7, and then that's going to be
Hold on.
cosine.
Isn't it -2? Is it a -2?
Yeah, maybe it is minus. Is it
Good,
minus?
yeah.
I gotta remember.
Yes.
Circumscribed. Is it circumscribed? Yeah, it's a squared b squared. Okay, cool. Got it. Okay.
You make a mistake like that.
I'm tired. All right. PRS is
Okay.
that. Although, to be honest, bro, Zach, did you stream for like 5 hours today, dog? I could not do that. My brain starts melting on the stream live if I have to do it for that long. I don't know how you do it that long. That's crazy. 6 squared minus 2.7 squared minus 7 squared divided by negative 14 times 2.7. That inverse cosine her. And we get 57.53 degrees. Cool. This is 57.53 degrees. Cool. Oh, that's what PRS is. Okay, so let me draw this separately. This is 57. Okay. Last question. 3.5-ish. Yeah, that's nuts, dude. They want us to find the area of the circle. Area of the whole circle.
They never actually asked me this before. Finding an area of a circle.
Okay. Uh-huh. I think there's something where, like, if I know what this angle is and I know the arc length of it, then I can figure out what the whole circumference would be, and then I can figure out what the whole area is. I think that's where that comes from. But I'm not sure about that. Determine the area of the circle. Actually, there's also another cool thing here. I can just have a I could have Wolfram just solve. Okay, solve angles in a I can basically have Wolfram Alpha do all the law of cosines for me. So here, you see how we have our these were our angles, which is cool. So now if I take these, I think we can do something cool with them. It's just to save ourselves some time.
Okay then.
Oh, that makes sense, right? That's where the 57 came from, right? That's this one. The 100 is obviously
Well,
this
honestly,
one, and then the 22 is this one.
How would you know?
I would just do law of cosines on all the angles. I just don't want to do them. It just would take time. I'm trying to see if that helps me. I'm just trying to see if that helps me. If I know what this angle is, and I know what these lengths are, and I know what this length is. Huh. Mm.
I guess you're having a brain meltdown.
No, not a meltdown. I'm just trying to think. Let's see. Area of triangle. Or no, I need area of circle
Okay
with
then.
triangle inside. There's probably something here. There we go. Sector area. Aha. That's kind of what I'm looking for. But that's if it goes through the radius. This one doesn't go through the radius. Say no radius.
What's it called? I think I can find a working here. I could share a screenshot and then send
Yeah.
it to you.
Yeah, send it to me.
Hold on, give me like a few minutes then.
Okay. Cool.
Where can I post it? Where can I post it?
Just post it in the chat.
Okay, hold on.
Post it in the chat. Post it in the chat. Bum.
See, hold on. This is how they did the first working. Hold on.
I already know. I need the last part. I just need the last part. I just need
At
this part.
least see it.
I don't
at
really
least
care
just
about.
see it.
I don't really care about the first parts. Just show me the last part. I already know how to do the
Alright
first part.
then.
I think it has something to do with this angle and arc length. It's just weird that it doesn't go through the radius, or it doesn't go through the center of the circle. I assume it doesn't. Yeah. Maybe there's something with this is equal to this. I can figure out the length of this. No.
Alright, so you want to see it?
Yes, I want to see it. Send it. Let me see it.
Alright. Here.
Okay. Where the fuck did this come from, dude? What?
That's what they have for working.
I feel like there's some information here that wasn't given.
Wow, really? They had this entire time.
They said 2 times the radius is equal to 6 over this. 6 over the sine of this. Where's the 57? Okay. Where does this come from? 2 times the radius is equal to 6 over this.
Isn't there a radius in that triangle?
No. We didn't say the radius was anywhere. The diameter. Okay. I think I know. Okay. There's probably a rule with chords, angles inside circles. I think there's something with this. And I need the radius in there somewhere too. Hmm. Where is that coming from, dude? Oh, okay. Wait. Here we go. This is what I'm talking about. This is why I kind of abhor geometry sometimes, dude. Because I'm just not going to remember all these things. There's so many different rules. Wait, can I just see this image, please? No, I need something with the... Yeah, I know about the double angle there. Mm-hmm. Where are they getting this from? Falcon, what's up, dude?
This trick too. I don't really know.
Well,
this
I just
stuff
don't. I have
like
no fucking clue where this comes from. Like, they can write this all day, but this doesn't tell me anything. This is saying the
So-
diameter is equal to the ratio of the side opposite the angle. Where does that come from?
So not even Hypatia will understand what that means.
Well, I just don't know where. I don't know where it comes from.
Wait, what? What did you say?
This question here, Hypatia here. I'll pull it up for you. This is.
Again?
I know, right? I know, dude. I'm so sorry, Hypatia. I'm so sorry.
Great.
Here, he's like, great. Yeah. Okay, we know that this angle here, Hypatia, is 57.54 degrees. And I'm just trying to find the radius. They're saying that 2 times the radius is equal to the ratio of this to this. Where does that come from?
Uh, hmm.
I was trying to find if there's something about like a chord, right?
Okay, let me think of wait.
Is it because this angle is the same for any representation of this, Hypatia? Is that kind of what we're getting at? Like, that angle has to be the same anywhere? Is that true? Like, this angle
I don't
equals this
think so.
equals this angle?
I don't think so. I mean, you like it's when you move that point closer to P, that angle is going to approach 90, right? Or more.
Yeah. Yeah, okay. Yeah, let me see that. Yeah, sorry. So you're
Wait,
well,
no, actually, no.
no, it won't.
I mean,
I think I see what's happening
okay,
here. I think you can pick a line from P to somewhere, right? Such that the distance here has to be 2 times the radius. I think that's where that comes from, right? Like, if I pick somewhere to connect these two,
Okay.
right? And then that
And
angle must
that
be the same.
angle, let me think about how to prove it. I mean, why does it have to be the same?
So 6 over the sine of the angle. Oh, they're saying this has to be 90 then, is what they're saying. Is that true?
Yeah, I think that's true because, well, because those two angles, they add up to. Yeah, because you can draw a tangent line at P and the opposite side, and also like parallel to S, and then you can probably see why it's 90 or.
Okay.
In fact, I think the way you prove like the angle doesn't change is also by tangent lines. I don't know how. I mean,
It wasn't this one. Where was it? It was. I think this was it. I think it was.
wait, what is this, Thai or Hebrew?
I know, right? I'm trying to find some here. Circle theorems. I just want a picture. I want to picture something. Come on, man! Don't do this to me.
Right click on a picture.
All right, here, let me
You
download.
can't. Like inspect the element. Try to do that.
Let me just try to open this. Oh, it's just so blurry. It's still so blurry. That's the issue. One sec. Fuck you, Pinterest. I need circle theorems. Here we go. This is what I think it is. I just need a high resolution one of it. Yes, there we go. This is what I want.
Great.
Good. All right. This is what I want. Nope, don't want that. Okay, I see it. Okay. So if right? This is what I was talking about. So if you have the same chord, no matter where you move these points, they will subtend the same angle, right? For the same segment.
Yes, that is true. It's like I've seen it on videos. They move
Okay.
around those things, but no matter where
Then
you go,
then
they're
watch.
always-
So here's what you can do. You can move this point somewhere to where it passes through the center, such that this is going to be 2R, and this will have to be 90 degrees.
I mean, it's like always the opposite of the radius, or the center is the
Yeah.
It's a
So
90
what happens
degrees.
is I'm gonna move this point R all the way to here, okay? Such that this is now 2R, which is opposite the 90, but this is still the 57 degrees, which is still opposite of the 6. So now I have sine of 57.54 degrees over 6 is equal to the sine of 90, which is just 1, over 2R. Okay, now this makes sense. So 2R is equal to 6 over sine of 57.54 degrees, which then you can solve for R. And then once you have R, Ethan, it's just pi R squared. So pi R squared, you get the area. Wow. Okay, cool. Done.
Okay. Everything else.
I'm done, dude. I don't want to ever see another triangle today.
Damn.
I really don't want to see any more triangles, dude. They've traumatized me. These triangles have traumatized me. What's up? Hey, Falcon, did you have a question you wanted to go over? I know you're working for your statistics and stuff. Let me know. Ugh. 2.5 hours almost. Wow. Yeah, I got a little bit more time. I got to go teach another kid. Luckily, I got to just teach him physics. So I'm happy about that.
I guess I'll go now.
Okay, cool. All right, let me see.
Hello.
Let me see if we had any other things, last minute things from. I didn't see. Okay. If not, it's all right. Cool. Let's roll out let's close out the stream. All right. Thank you everyone for coming to office hours today. I had a lot of fun melting my brain with Hypatia. Thank you, Hypatia, for sticking around. I really appreciate that. You're like the you know, like, have you ever watched like Who Wants to Be a Millionaire and it's like call a friend or ask the expert? I feel like that's what you are. Like when I can handle things, it's okay. But you're the lifeline, Hypatia.
I'm not a millionaire. Well, my parents are, but
No.
I'm probably not.
No. There's a TV show called Who Wants to Be a Millionaire. Do you ever hear? Yeah, okay. In this TV show, they ask these people questions like this, like they get a question, and they have different options that they can use every once in a while, and one of them is to call a friend. And so they get on. So on the TV show, they would like get on the phone, and be like, "I want to call my dad," and then they would ask their dad, like, "What do you think the answer is?" So this is an old reference. You're right. Probably no one actually knows about this show anymore because this is so old. So, but anyways, that's my metaphor. It's not that you're a millionaire or your parents are a millionaire. It's that if we were on this show, you're the friend I would call for I need help. Like if I had to phone a friend. Anyways, okay, cool. Next stream is going to be tomorrow, hour later. Starts at 5 p.m. 5 p.m. Pacific, 7 p.m. Central, 8 p.m. Eastern. And then, very cool, we're going to have our golden hour stream on Friday. We're going to have Penn Center as our special guest. We're going to do an AMA with Penn Center. I will announce that either later tonight or tomorrow. So please feel free to submit your AMA questions. Best question gets a $20 gift card. Last week it went to Half Alpha. Good job, Half Alpha, for your question. So you guys get rewarded for asking questions. Yeah, good. Okay. All right. Cool. So what we're going to do now is, if you guys want to still learn some math, hang around. We have some other great mathematics streamers that are in the community, and they do streams as well. I'm trying to think who's streaming right now. Oh, we got E to the Pi I. Cool. And we got Don's. Okay, so here, if you want to know about any of the other math streamers, there are all their links. Super cool people and whatnot. We're gonna go see Zach on E to the 2i Pi. I think he's doing a real analysis class, which I enjoy. So if you want to go learn some real analysis. Oh, it's okay. It's okay, Falcon. I was just seeing if you had any questions. But I gotta go now. It's okay. Submit your questions, Falcon, so I can help you next time with stuff. Okay. All right. So if you want to hang around and learn some math from E to the Pi I, we're gonna go do that. Otherwise, I will see you guys tomorrow, hour later. Enjoy the rest of your Wednesday, the rest of your Tuesday, sorry, and we'll see you on Wednesday. Peace.